Ignite. काम करता हूँ मैं रिप्लाई टू ऑल करता हूँ रिप्लाई ऑल मैं रिप्लाई कर देता हूँ सारे फाइल को प्लग से this file. Yeah. So right now I send another email. If you not extracted the RAR file, the separate file I will send. Each PDB, 2 PDB, 2 ITP, 1 TOF. And take this 5 file in one folder and the previous 4 script em.mdp, nvt.mdp, npt and md.mdp. That 4 script in same folder.
From the previous problem, we try to copy that npt, nvt and that other code that we have shared and we have modified. Copy that 4 files also in this next problem folder. Okay. Then if you want, you can make another folder for the given problem.
So kind of this type look, right, in directory. What are the file presents? If you see that, this is the this is the methyl imidazolium ionic liquid 4 file. Next to ITP file, this is a imidazolium PDB file, code script file, tetrafluoromethyl imide ITP file, tetrafluoromethyl PDB file, and TOF file. So okay, so shall I begin? After downloading this kind of views, you will see that directory. So when you open BMM ITB file in TextPad, so you will see that data actually kind of, but in OPLS force in leak, I created that force field using leak pargen actually. So leak pargen, what is the problem? Leak pargen given the OPLS 800, 801, 802 types of data. If you check the OPLS directory, there is no 800 present. So there is two ways you can do it. Either go to OPLS directory and update the FF bonded, non-bonded ITP OPLS 800, 801. Another way, you have to read the OPLS directory and understand which atom is saying. In leak pargen, what you downloaded, you get OPLS 800, 801, 802, that kind of force field. You already seen it down, right? So if you go to the GROMAX topology folder, there in OPLS, there is no 800 present. If you check that, then that's the problem, right? Because if OPLS 800 not present, the non-bonded parameter sigma epsilon doesn't present. So to solve this problem, you have two issue for solution. Case one, you update the force field top file and update with OPLS 800, 801 first in force field.itp, then atom type FF bonded ITP, FF non-bonded ITP. Type 2, case 2, which I did generally. So understand the OPLS directory, which is FF atom type ATP. You have written each atom, which is the type. Detailedly written means for thiol group, which one number, for methyl CHC, which is the OPLS number. So from that you can write this number and take that take that FF non-bonded ITP. Actually, I also cross-checked that when I started my simulation journey, that I see that leak parts in that parameter came and the OPLS directory parameter came are similar. If we modify OPLS 800, each time we have to change, right? Because suppose today I'm simulating methanol. Methanol also give OPLS 800. Tomorrow I simulate with the propanol or acetic acid. Same number will also give. That's the one major problem. So we have to read the OPLS directory. So it is totally tedious and you have to depot it. Then you understand. I already, that's why I given the force field file, which is OPLS during, and I created the net charge of the system. If you check that total charge should be +1 because imidazolone is a cation. And here also we take the bonded parameters, each in given in the format. So no need to update any data, bonded, angle, dihedral, proper dihedral, etc. You do not need to update. Just you have to update the first section only, the atom type section, right? Just that's atom section we have to update from the OPLS directory. Okay. So this is one of the ITP file. Another one of ITP file is this one. Another one is this one. Same way I did and manipulated it, and you will get the data. You can find in your GROMAX directory. GROMAX in directory there is one folder called top. They are that 15 force field data already given. And you can search in GROMAX website. There will also given the details of the force field zip file format. If you want, I will share it after that session. Okay? What are the force field available GROMAX by default, and then you have to read that way. So similar way, I update this one and create it. So after creating this, we have to create a top file. GROMAX, in GROMAX is still run. We see that when GROMPP need, one is top file, one is MDP, another is coordinate. Coordinate form with PDB to generate, but top file we need to create it. To create the top file, we use this type of functionality, which is in water molecule. If you open it, you will see that OPLSFF.forcefield.itp. Then which ITP I want to include, because there is no data available. Sometimes those few data are not available in the FF bonded ITP. To update, that's why this file is include. This is not a command. Huh? In GROMAX, semicolon is command and hash is include. This is not a command. To include that first ITP, okay, little bit change will be there. Okay, that name is not matching there. Actually, in folder you see underscore OPLS, right? Yeah. Yeah. Kindly make that changes actually. OPLS ITP. Then that's the ITP. Then it's the position restraint file. What position restraint file did? what position restriction file did now, when if you suppose you giving a motion and you want to constant some atom, to constrain some atom, you use the position restraint file. It will neglect the force, whatever you limit gives. For if you suppose give 1000 kilojoule per mole per kilojoule per mole nanometer, then it will neglect the 1000 kilojoule mole nanometer force. After that force coming, it will compute that. So it is one of the method to computation faster, and you can take easier to compute. It is widely used in protein simulation, because protein hydrogen atom is too much frequently moving. So to constant them, use that position restraint. Next is the BMMI ITP file added. Next, we use here is TIP4P water model. So we include them. And then is that's the water position restraint. And for ions, the ions.itp opls.ff के अंदर डायरेक्टरी में होगा present, and system name whatever you want to give. Okay, so for this problem we use 100 molecules of BMMIM1 and TFSI1 100 molecules, and other 3000 will be the TIP4P water model. Okay, but in theoretical, in practical, what is the water structure? OHO, right? So how many molecules present? 3. But in TIP4P, if you see, there is 4 molecule present. If you check the structure. So what is the fourth molecule? Actually, fourth molecule is an MW. What is MW? MW is an what is that called? Lone pair of the water. It's written in the MW. More accurate computation, it will be use the T4P. Save that tuple.top and go to the terminal. Okay. Yeah. So go to that folder using cd command. Not for the same for the everyone. It is based on your which folder you choose. But that /mnt is common. After that is your folder where you selected it data. Right? I think everybody get that. Is there any problem to get that folder? So next time move on then. So after that, GMX insert molecule. यूज किया था ना
ये WSL में अलग इंस्टॉल हुआ है, इसमें अलग हुआ है, ठीक है। सो CD डाउनलोड या ना सब अरे यार जीरो जीरो 10.0 minus 100
If we are trying to explain the molecules inside the box, the time. So we are making.
yeah,
If we appear with the
m dot
So this is the command to insert a molecule in our insert a molecule. Here is the input file is a new PDB which is already given to you. Box dimension 10 nanometer means 100 angstrom whole cube cubical box, and number of molecule is 100, and output name. Just after that enter. Uh, So after running that command, you will see that added 100 molecule out of 100 requested. Right, came everybody? So we go to the next step. Little bit more.
if then PT minus 200 minus 4 underscore underscore if dot go.
So after that command, we use this command. So what it did, actually, already we present the box which is imidazolium is inserted 100 molecule. So it take F as an input. It's the previous box. Then CI for the next input. We what we PDB input. This TFSI dot new PDB and the box dimension again and in molecular dimension and output file. It will generate same box after DMIM and the TFSI. But one thing matter, it is already placed in randomly. Okay, it is not placed in biphasic system. Okay, After that, you have to press enter. Yeah. F is for the taking the previous box as an input. Previous system input and CI to the next system. In GMX insert molecule, CI is the take the new molecule every time. Okay. And F is the for the previous molecule if you want to take. Yeah. ये में मानिए मतलब imidazolium. So after that imidazolium box, we name insert the TFSI molecule. TFSI. TFSI only. Next, water I will also generate little bit later. Copy from that one to a new one. Okay. So after entering, you see that is again is that 100 molecule added out of 100 requested on the previous molecule. If you check it in VMD, visualize it, you can visualize that image, how it will be the image. So to do that, open VMD and go to that directory where you are the molecule present. And load it. Yeah, kind of this kind of view will be you see, because that box is too much big for inserting the 100 and 100 atom. So, and it is if we see that there is two section, one is the ring section. Write the terminal PVC box command. Write this command in the VMD terminal, PVC box. PVC box. Write that command in VMD terminal. It will create show a box. Right? Are you created? Okay. If you see, there is two molecule randomly placed. One is ring site. I did not color code it, but if you want to color code it, it can possible. One is ring type molecule which is present. Another one is TFSI molecule. But if you see that this is a randomly placed, no order placed. Okay. So I hope this step I have already everybody completed. PVC box PVC box. The problem is यही फाइल कॉपी करने के लिए
আমার দেখে বারবার এটা সেন্টার মলিকিউলস মাইনাস এফ মাইনাস আগেরটা দিয়েছি আগেরটা হয়েছে আগেরটা insert molecule. That's we will understand what these blocks and misunderstood the GL. Source for
Next, we have to add the water molecule. So water molecule, adding it using this command gmx solvate minus cp for the configuration of protein or configuration of molecule minus cs for configuration of solvent p4p minus p2 okay. So gmx solvate is a command to solvate the molecule, water molecule. Already Gromax has several 6 solvated molecule. I already seen that in previous PPT. So we do not need to draw them each time. We just need to give the system, and we just give the minus CS2 for the configuration of solvent and which model we want to give it. For here we use the tip 4P, so we choose tip 4P. And minus P for the update the topology section, topology file. And minus O for the name of the system. And minus maxsol is given the maximum number of solvent molecule. It's help to control the solvent molecule. If you create an large amount of box, you know the system size, system molecule number, you can create it by controlling them using maxsol. It's a very helpful command actually. Okay, then press enter. It will generate it, and if you generate it, it will say that solvent has contain 4 atoms, which I already told it 40 model, and contain the 16,000 atom. Volume is the 1000 nanometer cube, and that system density, which also is compute 159 gram per liter. Not nearly 1000, but after NPT equilibration, it will come to the 1000. Okay, and yeah, and something that's kind of pro. Oh, yeah.
এইটা বারবার দিচ্ছে না এটা বারবার বলছে আপনার কমান্ডে মাইনাস বক্স বিএমআই মাইনাস বক্স এইখানে একটা রয়েছে কিন্তু মাইনাস বক্স বিএমআই হ্যাঁ তো মাইনাস বক্সটা কি আর এইটা এই বিএমআই এটা তার মাইনাস হবে না মাইনাস শুধু বক্স হবে আচ্ছা শুধু বক্স বিএমআই যেটা নাম ছিল সেইটাই নিচ্ছে তো এইটা তো মাইনাস করতে তারপরে সলভেটেড pmx solvent minus b AIP. The expert minus water and the silence में ना directly minus के बाद place वो water minus of Okay, that's all.
Mole, then this three command you can mark in one script and run it. That will be carried on combine PDB. After that, combine PDB, you convert in Go file using some edit connect file data. Yeah. No. If you have the mode, you can write, you cannot do not did that this three step. Write in one backward script which is already given, and from that script you need to get a PDF file after running that, and just convert that PDF file into Go file. Because in PDF file units are coordinate angstrom, but in Go file the units are in nanometer range. So you have to convert it. That's all. So after that we already completed. So there is something I have to do actually. Okay. Everybody follow this step. Is there any problem? Right. So move forward. After that, already we discussed what are the steps, similar step. So you will see that the command, and this is the run file after entering that, which is already we discussed broadly in previous session. After that, just do that same thing. Go MPP and MD run, and you have to check the each time. So I think everybody did that.
Anyone face any problem?
in after change করতে হবে নাকি next a plus I b max of a less থাকে ভিডিও রেকর্ড নেই তো ওই জন্য তোমরা কমপ্লিট করো ঠিক আছে দেখো আমি তাহলে এটাকে নামটা এখানে চেঞ্জ করে দিচ্ছি আমি করতে পারি না নেই ও কাজ এর নাম বানাই
So after running that, so next step is gmx md run. Minus m and v. So it will take some step and run it, and you will see that the force also came in
less than
1000 step and 34 step take to come there. Okay, after I do not plot after that. Okay, if you want to plot, you can plot it using whatever command I teach taught you, and comment for that this one.
yeah. এই তো এটাই তো এবার আবার সেম জিনিস তো DMX will be I think 85 does not exist. DFS does not mean every year for a your match is ask him if the robot not complete after that. अभी next is ये है
Okay. So after that, we move on to next step. Actually, in your
अच्छा एक लास्ट तक तो
Kunda,
that we last time we all that 1000 data code
हाँ,
last
GMX go mp3 minus a
minus a mp3 mp to all এইখানে আবার 4 এখানে আমাদের এখানে আবার বলছে কোঅর্ডিনেটস ম্যাচ করতে হবে এটা তো আমরা বলতে এরপরে এইটা হয়ে গেল মাইনাস আচ্ছা DAF M minus B
next NVT actually edit करना पड़ेगा system system so take that previous NVT script and again do it same procedure. Okay. So after that EM completion, you write this command, which is generated for the equilibration, NVT equilibration. There is one question actually someone asked me, I want to give answer. Why do we first do the NVT, not NPT? Because when you generate NVT, you generate the velocity. Till now, that system doesn't have velocity, single velocity. So when you give the temperature, based on temperature data, the velocity is generated using NVT. If you give the NPT initially, then you generate controlling the velocity, temperature, and pressure. So it is too much pressure, too much give the algorithm pressure. So there is chances to come some error. To encounter that error, we always do at least 10 picosecond of NVT, which generates the velocity and temperature. Then you generate the do the NPT. Everybody follow it. Write this command, which is for the NVT equilibration, and enter. So command is there if you need, right?
One. DNX strong minus F NPT dot NPT. Component minus P total dot top minus C EM dot pro.
nbt.grow.
Huh?
nbt.grow.
NPT dot pro.
nvt.
VT तो volume तो. NPT dot pro और output है NPT. Okay. Bit wrong. Minus minus yeah. এনপিটি ডট কি রাখা এটা এনপিটি হবে না।
No, equilibration. NPT. .tpl. So write this command gmx go mpp minus f minus p minus c and minus o np.tpl. Same command. Then enter. So there is no error and nothing. After that, okay. Yeah. Actually, in Glomax, there is the easiest step. After preparation the system, there's two command in it: go mpp and md run till production. Sometime energy file is you have to analyze, see that whether system is well equilibrated. Else case, just go mpp and md run. Okay, everybody did that? So next step is to run the md run using this command. So, अरे यार, ऑप्शन है ना, ठीक है स्क्रिप्ट ना, अरे वो ये हो गया है 1 नैनो सेकंड का रन था, 1 नैनो सेकंड होगा तो कमांड बच जाएगा, तो इसलिए मुझे इसको टर्मिनेट करना पड़ा. Yeah. It will cover in 7 minutes, 100%. उससे कम कैसे कर सकते? The command is gmx md run.
असल वो सिस्टम का भाई जीपीयू नहीं, जीपीयू पर सामने मतलब कुछ ऐसा स्टेट में गया है सिस्टम नहीं तो ये सिस्टम आने के बाद
So after completing the NPT, you said that performance quite good. So just check the system is well equilibrated or not. To check that, use energy file and just check the density. Yeah. So then 16 and 0. Wait, 16. No, 16 0 not.
16.
23 0. Kubi, kubi.
We are taking for the density. Problem is we are getting 20.
So for that comment is this one GMX energy np dot idiot density dot xbg and to select 23 then 0 for the only say 23 to choose the density function. So if you check that our average density is 995, but water density is 1000. So our simulation is accurate. Our system is fully equilibrated. Then we can go for the production run. Outside water enough. And kindly change the state. Okay, this state in md.mdp because we do not want to run the 1 nanosecond simulation. Actually, 1 nanosecond is a very good, but here we only run for 500 picosecond to analyze. In md.mdp script. Yes. Just change the state because previous script, according to previous script, your state is 1 nanosecond. So we need to change it 500 picosecond. It will be the little bit faster. And save it. Everybody follow that time, right? কেন? দাঁড়া দেখছি। So write this command. So after that, we'll go to this run. Uh, hmm? Yeah, use this command.
अच्छा इतना GMX लिख MP run underscore 01 PPR FNM MD ये फिर ये वाला चेंज होगा MD01. MD01. MD underscore 01. देखो. Alright. हाँ मीटिंग है. और नहीं होगा तो समझ में finish witness
उसके बाद भी 50-50 नीति काम करते हैं बोलेंगे एनालिसिस पिछले से किया था उसका 4 बजे तक ये खत्म होने के बाद तो सर आरडीएफ का अकाउंट को सिलेक्ट ये करना पड़ेगा ना बोलना पड़ेगा वो बोलना पड़ेगा कैसे क्यों बोल रहा है कैसे क्या करते हैं एनालिसिस का जो पहले या पता है पड़ा है सर इवन वाटर क्लियर में नहीं आपको कैसे कैसे करते हैं ऐसा बट So due to time constraint, we have concluded this session and analysis will be same way we already did in water. Same way you can choose the RDF plot in atom, then plot the RDF and hydrogen bonding between the different IL and waters. And also check you can check the mean square displacement. From the mean square displacement data, you can get the diffusivity, which is already given to that PPT in water. Okay. So here we can conclude here. So yeah, I will say happy simulation.
Yeah, so this actually brings us to the conclusion. What is this? This slide. Okay. So by the time he is just setting the title slide, so this brings the conclusion of this session, and it's valid for the event also. So like Rantu has said, first of all, I should actually thank both Rantu and Kasi for conducting this session. They have conducted it very painstakingly, all the steps. They made you learn all the single steps. Something you should also try when you go back. So Gromax, as you know, it is freely available. And but you should also read the theory behind it. Like what is RDF, what is energy, what do they do, what physical insight it provide. That's why you learn this software and I get some data, you analyze, you plot, and publish. Don't do that. So try to see what you get out of it, what physical insight you get, whether you get a transport property or any physical phenomena. What that is very important. Whether it is not only for MD, it is applicable for Monte Carlo and QC also. Where you want to use, which technique you use where, that is which application. So that is all simulation is all about. So I also, first of all, I would like to then thank Dr. Devakesh for his excellent introduction to molecular dynamics simulation yesterday and today's hands-on session. So on behalf of I would like to present a small memento. Yep, thank you. So then we will start with the shall we take a photo? Feedback. You have given the feedback, everybody? Yes, on the file?
Yes.
Okay, so now if I like to hear from you actually. Is it okay? So anybody wants to give a general feedback, then we will distribute the certificate. Have you prepared some names?
If you by your own choice, if you come, then it will be better. Otherwise, you can call random name. You can come here and give a feedback.
Then I will do a vote of time after that.
Yeah, ma'am.
Okay.
Very good evening to all. And first of all, I'm very thankful to Taman sir for allowing me to come over here. And I have learned a lot over here. The hands-on section, it was very good. That I was novice to all. Means I was thinking that I'm in the nursery class and you all. So I have learned a lot. Many terminology I was not acquainted with, and here I got many. So I'm very thankful to all and Ragibul, Rajiv, and Raymond also, and all the that want to also Rontu also did a good, means lecture was good and tutorial was good. So I'm very thankful to all for this kind of event, and the organization organized, well organized, food also very good.
Okay.
I have something for you.
Anybody else?
From IIT Madras.
Everyone. So this was a very unexpected event. although very, very enticing because many of the things that were taught are not known by a lot of people who are trying to expand their domains. As an experimentalist who is trying to venture into the domain of computational chemistry, quantum, and the DFT, it gave me a great insight on the things that are required, the things that are desired out of a computational chemist or an engineer. And this will definitely be the basis of my career in building it up throughout the journey I'll carry.
This side. Yes, yeah, on the screen. Okay. What's your name? So,
Actually, this and Luponi has already said, so I am also coming from an experimental background, trying to implement analysis of molecular dynamics simulations on a scale. So I think for an introductory session, the sessions were a bit difficult during the theory part, but after during the application, like when sir explained it along the way, that was very nice. Especially during hands-on when we were like every time, every code that was like we were explained why we are utilizing the code. I think that was very helpful. That is where like all the we'll get the recordings, I think.
Yeah.
Yes. So any kind of doubt also, any doubt, yeah, we can refer to that. Thank you.
Anyone wants to come?
Voluntarily, anybody wants to come?
Raymond? Same. Okay, sir, then please.
Okay, nobody? Fine. So maybe I'll try the vote of thanks because of which it would not have been possible. So first, let me thank all the speakers first. Dr. Musharraf Ali in the first 2 days for his introduction to quantum simulation and periodic DFT. And then Dr. Ashok Das Mahapatra, where he introduced Monte Carlo simulations, followed by Dr. Anand Bharti, where he had introduced the Story package. And finally, the last 2 days, Dr. Devashi for introducing the concept of molecular dynamics. Then the hands-on session would not have been possible because of taking some work a lot. Yes, like I was saying, this giving a huge amount of and then after that, both of them have conducted this quantum chemical calculation, and I hope you have now got all the steps, so you can now at least start not from scratch, but you can take it further. And then the other case for the Monte Carlo, although even though Monte Carlo, I think we all managed, but I should again thank Dr. Anand Bharti because he has been very helpful both as an instructor, a resource person, as well as a TA. Because we, in fact, in our group didn't have anybody who could help us in Monte Carlo simulation. So he's the only one. He actually was there for the entire 2 days, attending to each and every query, solving each and every problem. So hope you have learned it. And finally, coming to the concluding 2 days, so we want to thank Subhash. You can stand up. So, yes. And also thank the other organizing team for taking care of other aspects of this value channel. Mr. Nipudas for and Mangal, very senior. And Rajiv for everything else and other certificates for another session and other activities, all he has been taking care of, Rajiv. And Arindam is not there. Arindam for the inaugural session. So we are anchored in inaugural session. Am I missing anybody? Hopefully everything is covered. Huh? Okay, all our basically lab members, even if I miss somebody. Okay, thank you. So now, anything you want to add, organizing member, anything you want to add to me?
It is also a good experience for us also because conducting this type of workshop in even it is small, but we learned a lot of things, and also it gave me a good experience with you in the learning experience, because we learned a lot of things, but never we expressed with the other students. So it is also a good means experience for me all, and for that, thank you all.
Thank you. So this group has been created already. So keep in touch for any simulation activity or any help. So I will also add you also, the resource person also. Probably who is not added, we will add the resource persons also, so that you will get instant answers. So this group will stay and hope it builds up in the near future. You can have another Carichala even. It will also help maybe some other aspects. Maybe only on quantum chemical calculation, because as you know, it takes a lot of time. Okay. So that's all for the today. Obviously, IIT Guwahati has helped us, our administration, for these facilities like computer center and other activities. I should also thank even though he is not here, the head of department for helping other activities. So with that, I will stop here. I will conclude the Karishala and we will now distribute the certificates. I will call the name one by one. Achilles. Full name. Achilles. Achilles Upasani. Priya Yadav.
Yadav.
Gujarati. Vijay Kumar Pandey. Himani Singh. Tuja Devi. Anuj Tehna. Anuj. Anuj Tehna. Vikas.
Vikas Kumar Sinha.
Vikas. Vikas. Vikas.
Raj Aksar.
Pawan Kumar. Raj. Pawan. Karnati Ganesh Reddy. That's it. Saurabh Kasti. Malik Rehan Ahmed. Praveen Kumar. Mahima Devi. Mahima Devi. Kostopna. Kost. Benjo. Dr. Jyoti. Oh, this is this goes for the entire organizing team. I guess. क्या प्रवीण का था मस्त आलो कौन तो शिशु भी रन एक घंटा बाद अंतली बैठे को ऑन काउंटर कोड की कोड हम करते हैं हाँ रिपेल डाउन इनको बाहर रहती है मेरे पास आ ऋषिकेश शर्मा दस से बढ़ गया ऋतुराज ऋतुराज to do it Mazauddin
I'll ask Devashish to come and hand over. Come. Then we can hand over. Actually, it will be honored okay, to receive the certificate from your hand. Okay, you can stay there. I can stay. Okay. Mazal.
Thank you, sir. From Toda. Ramandana.
Boleh kan lagi, jadi kan. Tam.
Lagi pun bisa.
Awesome. Angkat.
Deepak Kumar Das.
Eight jump scores this.
Arindam Dutta. Samin, you can collect this.
Aluminum to. Okay.
Samin, you can collect. Samin का extra करेंगे.
एक blank वाला Anybody left? Nabendu, anyway, Nabendu, he has left already. So he was there in the first 3 days. So he was there on the all the members. Okay, that's it then. Just enjoy your stay. Okay. So how many of you are leaving today? Okay, few of and most of them are meeting tomorrow, right? Okay, we can have a group photo. Group photo we had in the first day, we can have it here also. There is like